Hello, this is a PowerPoint presentation called Algebra Word Problems Made Easy. What it is going through a few of the typical types of algebra word problems you get in a Algebra 1 class and usually also get again in an Algebra 2 class. Um, and I'm going to start off with the easy ones that you may have seen in a pre-algebra class before, and then we're going to work our way up to the more difficult problems. This video will only contain some of the types of problems, some of the more difficult ones like the distance, rate, and time problems, like two trains leave at a certain time and so forth. We will cover those in a second video. But now, the first thing to remember is that there's a general method to solve all these problems. And if you use this general method, um, it's going to help you a lot. The other things you need to do is see a bunch of different problems. Once you see a bunch of different problems, you sort of get the tricks of the trade a little bit. You sort of figure out what's happening, and you will be able to, use your creativity and imagination to solve some pretty difficult problems. So, as far as the general methods to solve, as you can see, I have written down there. First, read the problem carefully. Don't rush through these. What I've done here is I've given you short little explanations of a problem or abbreviated problems, and I've called out the most pertinent information here already for you. But when you read a problem, you need to figure out what's being asked, what's important, and so forth. So you'll need to do that. Now, often it's good to draw a diagram too. On some of these in this video, a diagram isn't that important. When you get to the distance is equal rate times time problems, a diagram is almost essential, okay, for you to understand what's going on and to be able to write the equation that you'll need. And as I say here, remember there's more than one piece of information missing in all these problems. Okay, so after you've read the problem carefully and done the initial things, this is what you need to do. You're going to define a variable. You're only defining one variable. It's going to be something like let n equal, and then describe something in English. So let n equal the number of hamburgers sold, or let n equal the dollars invested, something like that. Later, not in this video, but in another video, I'll show you how to do these with simultaneous equations too, where we could have more than one variable, but right now we only have one variable. The second step, and you can see that I've color-coded these, and I've color-coded these throughout the video, and I have these steps down for each problem. So I put it in red here. The next step is using the same variable here, n or x or whatever it is, but only one variable. You're going to define the other unknowns, and I'll show you what that means. Then you're going to write an equation. Then that's the purple. In the green, you're going to solve the equation for that variable. And then the final step is after you found the variable, what the variable is equal to, you're going to go back and find the other answers to going back to the definitions you made when you defined the other unknowns in the red step here. Okay, with that, let's go to the first problem. So these are problems that you are exposed to first in pre-algebra classes. So it's the classic three consecutive integers whose sum is 39, for example. So what you're going to do is first define a variable. Here it makes sense as defining the variable. The blue step here is let n, or here x, let x equal the first integer. Okay? That's your choice. Defining the variable is your choice. We don't just want to find the first integer, though. We want to find the second and third also. So they're going to be defined in terms of x. So if these are consecutive integers, there would be something like 2, 3, 4, 12, 13, 14. So if I go from 2 to 3, I've added 1 to the first integer. So I can say x plus 1 is equal to the second integer. Well, let's take three integers again, consecutive integers, 2, 3, 4. To go from 2 to 4, I add 2. So I'm going to say x plus 2 is equal to the third integer. Now we're going to write an equation. And basically what we're going to do is we're going to say the first integer, x, plus the second integer, x plus 1, plus the third integer, x plus 2, is equal to 39. So I'm going to go ahead and do that. And you can see I have x, the first integer, x plus 1 the second, x plus 2 the third is equal to 39. I'm now going to solve this equation. I'm going to combine like terms. So x plus x plus x is 3x, and 1 plus 2 is 3. So I get 3x plus 3 is 39. Subtract 3 from both sides. I'm not showing this here because it's a little hard to show on a PowerPoint, but I'm subtracting 3 from both sides of the equation, and I get 3x is equal to 36. Divide each side by 3, and I didn't show that there, but I'm dividing each side by 3, and I get x is equal to 12. Okay, now we have that. Now we're going to go back and find the other answers, and I do that by x plus 1. If you remember back here, x plus 1 is equal to the second integer. So x plus 1 is equal to 12 plus 1. And that's equal to the second integer. So the second integer is 13 here. I didn't put that down, but it's 13. And x plus 2, going back here, is equal to 12 plus 2, or 14. And so the third integer is 14. Okay, so that's the three consecutive integer problems. You will often get problems of something like 3 consecutive even integers or 3 consecutive odd integers whose sum is something. Those are solved in just the same way, except it's let x equal the first integer, x plus 2 is equal to the second integer, and x plus 4 is the third integer. That's the same for whether it's even or odd, because let's take 3 consecutive odd integers. Let's say 3, 5, 7. To go from 3 to 5, I add 2. To go from 3 to 7, I add 4. So it's the same whether it's odd or evens. Okay? Now, we're going on to a different type of problem. Here's a classic. We have a triangle. They say the second angle is 20 degrees more than the first angle, and the third angle is twice the first angle. Okay, that can get pretty confusing, but you take it down, and you know, they may give you some other information and so forth too, but you take it down to the essentials and you say, well, I have 3 angles of a triangle, 3 angles in a triangle. I know those 3 angles add up to 180. They're telling me enough information to figure this out. So let's start by defining a variable. I'm just going to say let n equal the first angle. Okay? Now how we do the other ones? Well, if n is the first angle, we know the second angle is 20 degrees more than the first. So the second angle is going to be n plus 20. So we get n plus 20 is equal to the second angle. The third angle, it says, is twice the first. Twice the first means 2 times n, or 2n. So 2n is equal to the third angle. From this, I'm going to write an equation, and I have these 3 angles, the first angle, the second angle, and the third angle, or n plus 20, that's the second one, plus 2n, the third one, is equal to 180. So we use this math fact here, geometry fact, that some of the angles of a triangle, interior angles of a triangle, add up to 180. Now, I'm going to solve the equation. First, I'm going to combine like terms, simplify where I can. So I get n plus 2n is 4n. So I get 4n plus 20 is 180. I'm going to subtract 20 from both sides, and I get 4n is equal to 160. going to divide both sides by, I don't show it here, but I'm dividing both sides by 4, and I get n is equal to 40. That's the first angle. We're going to have to find the second and third angle also. So we go back to this. We know that n plus 20 from back here is the second angle. So now we know that n is 40. 40 plus 20 is 60. So 60 is equal to the second angle. The other one, the third angle, we know is 2n. So 2 times n, or 2 times 40, is 80, and that's the third angle. We can check our work by saying 80 plus 60 is 140. 140 plus 40 is 180. And so we have it, 180. The next type of problem is, I'll call it the coin problem. They usually go in something like this, and there's variations, and you may have to have a slightly different equation, but one way is I have 22 coins totaling $1.55 in nickels and dimes, okay? And the question is how many nickels do I have and how many dimes do I have? So when you're defining the variables, you either pick the nickel or the dime, and you say x or n or whatever it is going to be, here I said let n equal the number of nickels, okay? And makes sense here for n for nickel, okay? If n is the number of nickels and I have 22 coins, the number of dimes must be 22 minus n. So that's my second step. 22 minus n is equal to the number of dimes. So in other words, let's go back to this. I have 22 coins total. If I have n nickels, the rest of the coins, or 22 minus n, must be the number of dimes. Okay, I'm going to write an equation. And let me show you the equation and then explain it to you. It goes like this. The value of a nickel, the monetary value of a nickel, is $0.05. So if I take the value of a nickel times the number of nickels, that's going to give me the dollar amount in nickels. Okay? In other words, let's take another example. If I have, and again, this is different from this problem. If I have 10 nickels, I have 50 cents, right? Because 10 times $0.05 is equal to 50, or 0.50, or half of a dollar, or 50 cents, okay? So I take the dollar amount, the dollar value of one nickel times the number of nickels. That's going to tell me the dollar amount of all the nickels I have. Well, same thing with dimes. If I take the dollar amount of a dime, a tenth of a dollar, okay, so a dime is a tenth of a dollar, and I multiply it by the number of dimes, and we said the number of dimes is 22 minus n, so we go 22 minus n, that's going to give me the dollar value of all the dimes. Well, if I take the dollar value of all the nickels plus the dollar value of all the dimes, that's going to give me the total amount of money I have. So there it is. I have 0.05n plus 0.1 times 22 minus n is equal to 1.55. Next, I'm going to solve that equation. You probably see right off that we're going to have some distributive property here. We're going to have 0.1 times 22 minus 0.1n. Okay, so let's look at that. So again, so we have 0.05n plus, so that was just copying that, plus distributive property, 0.1 times 22 is 2.2. 0.1 times negative n is, we got minus 0.1 n here, is equal to 1.55. Combine like terms. We have 0.05 n minus 0.1 n. That's equal to negative 0.05 n. Don't get concerned with the negative right now. It's going to work out okay. Okay? It's going to work out okay because the next thing we need to do is get rid of this 2.2. If I subtract 2.2 from both sides, so subtract 2.2 from this side and subtract 2.2 from this side, I'm going to get another negative on this side because 1.55 minus 2.2 is going to give us a negative. So look at that. I get 0.05n is equal to negative 0.65. I'm going to divide both sides by negative 0.05 to get n by itself. And now look, we got a negative divided by a negative. It's going to be a positive. It's going to work out okay. And I do that, and I get n is equal to 13. It's 13 nickels, I know. Okay? Now I'm going to go back to my definition here for dimes. I got my number of nickels already. I'm going to figure out the number of dimes, and so I'm going to go 22 minus n. So I go ahead and do that, and I go 22 minus n is 22 minus 13, or 9 dimes. Okay, I could go check that too. So 9 dimes is going to be 90 cents. 13 nickels is going to be 65. If I take 90 plus 65, I get $1.55. So 90 cents plus 55 or 65 cents is $1.55, which is exactly what I have. Okay, so that's the, I'll call it the nickel and dime problem. Okay. The next type of problem usually goes like this. It's usually somebody, a fundraiser, you know, the 8th grade fundraiser, and they're selling hamburgers or hot dogs or apples and oranges or something, or, you know, lemonade and grape soda or something like that. But they're selling a couple items. And here there's hamburgers and hot dogs. So I call them hamburger hot dog problems. So hamburgers are $2.50. $2.50. Hot dogs are $1.75. And they're going to tell you some more facts about these. So they're going to tell you the price of the items, and they're going to tell you the number of items sold or something like that, and they're going to tell the total sales. There could be little variations, but this is sort of how they go. Okay. Two things we want to find out. The questions they're going to be asking is, how many hamburgers were sold? How many hot dogs were sold? They could have something like total items and so forth too, and we'll get some practice with those kind of things. But right now, the question is, how many hamburgers were sold? How many hot dogs were sold? So I'm going to say let n equal the number of hamburgers. Okay? I probably should have chosen a variable that like beef or burgers or something like that, but that's okay. So let n is equal to the number of hamburgers. I define the other unknowns in terms of that variable. Well, we know there was 130 items sold, 130 hamburgers and hot dogs combined sold. So the number, if n's the number of hamburgers sold, the rest of the stuff must be hot dogs. Well, the rest of the stuff is 130 minus n. Okay, so we get 130 minus n is the number of hot dogs. We're going to write an equation. You'll notice the similarity to the nickel and dime problem that we had before. These are going to be real similar to the solution or mixture questions we're going to have in a later video also. So we're going to write an equation. I'm going to show you the equation I came up with. It's 2.5, that's $2.50, the dollar amount for a hamburger, times the number of hamburgers, and that's going to give us the total money received for hamburgers. Okay? Similarly, I take the dollar amount for one hot dog, $1.75, times it by the number of hot dogs right here, and that's okay, and that's going to give me the dollar value for the hot dogs, all the hot dogs. So if I add the dollar amount for all the hamburgers plus the dollar amount for all of the hot dogs, that's going to give me the total take that they get for these hot dogs and hamburgers, $2.65, that I'm told in the problem that they add up to that. Now I got to solve this equation. You can see that I'm going to have some distributive property again. I'm going to go 1.75 times 130, and then 1.75 times minus n or negative n here. So I'm going to have that. So let's look and see what we got. We get this if we apply the distributive property. So I'm not going to go through the exact calculations, but this is what you get. Combine like terms, 2.5n minus 1.75n, I get 0.75n plus 227.5 is equal to 265. Subtract 227.5 from both sides. When I do that, I get 0.75n is equal to 37.5. Divide each side by 0.75. And I end up with n is equal to 50. Again, n is the number of hamburgers. So the answer is 50 hamburgers. To find the number of hot dogs, I'm going to go back to this definition here. 130 minus n, the total number of items minus the number of burgers, is the number of hot dogs. So I go back to that. I go 130 minus n, or 130 minus 50 is 80 dogs. So we sold 50 hamburgers and 80 hot dogs. That's our answer. Okay. One more problem in this video. This is an investment problem. I invest $30,000 for 1 year. I made it easy here for 1 year. Part at 2%, part at 3%. The total earnings are for that year are $800. So, at the end of the year, I'm going to have $30,800 as my balance. But the earnings, or the interest earned, is $800. Okay, define a variable again. This looks really difficult, but it's very similar to the hamburger hot dog problem. Basically, we want to know how much was sold. The question will be, how much did we invest at 2%? How much did we invest at 3%? Or they might just ask you one of those. But usually, they'll ask both. So how much was invested at 2%? How much was invested at 3%? Well, we're going to define a variable. I can say let n equal the amount at 2%. Okay, I chose 3%, the amount 3% too, but I chose the amount at 2%. Define the other unknowns in terms of that variable. Well, if n dollars was invested at 2%, the rest of it, or $30,000 minus n, had to be the amount invested at 3%. Okay? Think of this as being invested at Bank A and Bank B. Well, if I invest n at Bank A, the rest of it, or 30,000 minus n, is the amount I invest at Bank B. So $30,000 minus n is equal to the amount I'm investing at 3%. Going to write an equation. I'll show it to you again. Look at the similarity to the nickel and dime and hamburger hot dog problems. By the way, you need to remember the formula for simple interest. I is equal to PRT. Interest is equal to so interest, the amount you earn, is equal to the principal, the amount that you are investing, times the rate of interest as a decimal. So 2% is 0.02, 3% is 0.03, times the time here in number of years, since these are per year or per annum here. Okay, so remember I is equal to PRT. So we're going to write an equation. Here's the equation. This little thing here is I is equal to PRT. This is the PRT. And this is the PRT for the amount invested at 2%. So I invested n dollars, that's the P, the principal, at 2% for 1 year. Plus, I invested the rest of my money, 30,000 minus n, at 3%, the rate, the R here, so principal, rate, time, this is for the amount at 3%. So the interest I've earned for the 2% investment plus the interest I earned for the 3% investment is equal to $800, we're told in the original problem. Going to solve the equation. Here, this is just going to be 0.02n. Here, I'm going to have some distributive property. You could multiply this first, and it's just 0.03 here because it's times 1. A lot of people are more comfortable taking this 0.03 and putting it to the left. That's perfectly fine. However you do it, you're going to have to use the distributive property. So it's going to be 0.03 times 30,000 minus 0.03n. Okay? So we end up getting 0.02n plus 900 minus 0.03n is equal to $800 after doing that distributive property. So next, I'm going to Combine like terms, and you see I have 0.02n minus 0.03n. I get a negative 0.01n. Don't worry about that yet. Don't worry about it at all, really. It's going to work out okay. Next thing I'm going to do is subtract 900 from both sides. I go ahead and do that. I get 0.01n is equal to negative 100. I divide both sides by negative 0.01, and negative divided by a negative is positive, so I end up getting n is equal to $10,000. N, remember, is the amount invested at 2%. Go back to this, I remember that 30,000 minus n is the amount invested at 3%. And so 30,000 minus 100,000 is 20,000. So my answer is 10,000 was invested at 2%, 20,000 was invested at 3%. That's it for this introduction to solving word problems. Things to come is, again, we're going to do that distance is equal rate times time problems. The train or the buses, or somebody forgetting their briefcase and somebody catching up with them, all those types of problems. In the mixture problems, solution problems, as far as like chemistry class or baking or something like that. Those are among the most difficult, but those things to come also follow the exact same pattern that we've worked with here. So with that, I will go ahead and end my video.